Hello, in today's video we're going to be talking about the mass percent, but unlike what we did with those marbles, that example of that box of marbles that had red, yellow, and purple marbles, we're going to be using the mass percent of each of the elements that are present in a given molecule. So let's see what we would need. I'm going to manipulate the equation that we had for those marbles and change it into something that's relatable to formulas. So the mass percent of any element is going to be equal to, we knew that in the marbles it was the mass of each of those marbles, so it's going to be the mass of the element divided by total mass of the molecule, and then we're going to multiply that by 100%. And that's our equation for finding the mass percent of any element given in a given compound or molecule. So let's take a specific example and let's figure out what the mass percentage is of one of those elements that's found in that molecule. So let's take octane. Octane's formula is C8H18. Now, in order for us to find the mass percent of, let's say, carbon in this case, we would have to know the mass of the carbon and the total mass of this molecule. Well, if I were to only give you this information here, that's not enough information for you to calculate this problem. But we can do something, we can do a kind of a trick. We know that the mass percent never changes based on the amount of the material. So if we had 100 grams, the mass percent of carbon is going to stay the same as if we only had 1 gram. So in this case, let's make our math easy. Let's first assume 1 mole of this molecule. So we're going to assume 1 mole as our mass. So we're going to assume 1 mole of C8H18. And the reason we're going to do that is we know that the molar mass of octane we can calculate from the periodic table. So if we have the molar mass of octane, molar mass is equal to 114.26 grams per mole of this octane, and we multiply by 1 mole of this octane, we know we're going to end up with grams. So let's take this, let's multiply this by 1 mole of C8H18. The moles cancel, we're left with grams, and now we have 114.26 grams of C8H18. That is our total mass. Now we have to perform the same type of calculation with the mass and find the mass of the carbon. Let's say we're finding the mass percent of carbon here. So I'm going to do the same type of thing. I'm starting out with my 1 mole of C8H18. I'm going to convert that into moles of carbon. We figured this out, and we figured out how to do this on the previous videos on last lecture. So we know for every 1 mole of C8H18, there are 8 moles of carbon. We know this from the formula. There's 8 atoms of carbon for every 18 atoms of hydrogen for every 1 molecule of octane, or for every 1 mole of octane, there are 8 moles of carbon or 18 moles of hydrogen. The moles of octane cancel here. We can continue on this calculation. Multiply by 1 mole of carbon, multiply by the molar mass, 12.01 grams of carbon. The moles cancel, and we're left with 96.088 grams of carbon. Great. Now we have the mass of the element, we have the mass of the molecule. All we have to do is plug this into this equation. So I'm going to erase everything here. I'm going to keep these final numbers that are over on the right, and I'm going to use them. So now if I wanted to say the mass percent of carbon is going to be equal to the mass of carbon, which is given here, 96.088 grams of carbon, for the total mass of the molecule, which was given here, and we calculated that, 114.26 grams C8H18. Multiply that number by 100%. We end up getting a value of 84.088%. Now, the Sig Figs here are a little different, that assuming 1 mole, we're going to treat this as an infinitely significant number. It's a countable number. We had exactly 1 mole. So we know that this doesn't play a part in dealing with our significant figures, but the molar masses did. So for the molar mass of carbon, there were 4. For the molar mass of octane, there were 5. So there should be a total of 4 in our final answer. So this should be rounded to 84.09% carbon. We can do the same type of calculation for the hydrogen. I'm not going to perform that here, but we're going to do a lot of these in class tomorrow. We'll work forwards and backwards on these types of problems tomorrow. And with that, that's all I want to say about the mass percent of using formulas. And like I said, we'll do a lot of these tomorrow in class. See you all then.